Welcome everyone to iComply 365's webinar, Everything You Want to Know About Encryption for GDPR Compliance, but We're Afraid to Ask. Our goal today is to provide you with an objective framework for making decisions about the adequacy and cost of existing or proposed encryption solutions. We're going to talk about what the GDPR expects encryption-wise. We're going to go over how to evaluate existing or proposed encryption solutions. We're also going to examine tools for documenting encryption for GDPR compliance. So let's start with what the GDPR expects. And it's pretty obvious. They expect for data to be protected. And in their world, that means that there are no reportable breaches. It's just that it's not necessarily that information doesn't get out there. It's just that if it gets out there, it's unusable. And that's sort of obviously the purpose of encryption. There are different kinds of breaches that they don't want to see. The first kind is confidentiality breaches, and those come in about three different flavors, right? There's infiltration, which is just the unauthorized access to data. That can take place inside of a company or from outside of an organization as well. So you can have somebody inside an organization who sees stuff that they're not supposed to see. That is an infiltration. You certainly can have a circumstance where you have compromised credentials and somebody from the outside is able to log in as a legitimate user and see things they're not supposed to be. That's an infiltration breach. You also have exfiltration, and that's probably the type of breach that we're most familiar with. This is what usually hits the news, and that's the unauthorized copy and transfer of data to some authorized device outside the organization typically, and that transfer can be done via email, it can be done via text, it can be done again from the inside, from portable media, in any somehow or another the information gets out and it gets on a computer, and then somebody has access to that computer that's not supposed to have it, and you have an exfiltration, right? Then that can be done accidentally. As well as obviously maliciously. It can be done again by compromised credentials, malware, and so forth. And then you just have plain old interception, and then that's the capture of data in transit, and that's some of what encryption guards against. You also have integrity breaches, and an integrity breach is simply when you have the unrecoverable, accidental, or malicious data alteration. And the key word there is unrecoverable. If you are able to discover that data has been somehow altered in a way that you didn't intend, but you can roll that back to a known good state, then it's not an integrity breach. It's only when it's unrecoverable. And then you have availability breaches, and we think of those as denial of service. That denial of service can be from a single computer. It can be a group of like a botnet. Then you get distributed denial of service. But in any eventuality that a breach occurs when somebody is unable to get to their data in a timely fashion, encryption plays a large role in the confidentiality and integrity breaches, which we'll discuss more, but probably a lesser role in availability breaches. So one of the things that GDPR expects is a pretty thorough assessment of encryption solutions. And I've taken a section here from Working Party 29 Guidelines on Personal Data Breach, the latest version, which was back a little over a year ago, back in October 2017. And they state that a failure to comply with Article 33, which is the breach notification, will exist where a controller does not notify the supervisory authority in a situation, and I'll notice I've got this highlight, where the data has not actually been securely encrypted. And please note the bold of the not actually. And it's interesting, and you'll understand why if you read a lot of the background documentation that went to formulating the GDPR, that encryption is not magic. Just because encryption has been applied does not mean that breach data was encrypted. So it actually is on the burden on the organization that's deciding whether to report or not, to be able to show that they have a high degree of confidence that any breached data was actually encrypted. In other words, what people who were not supposed to see saw was unintelligible. Therefore, when selecting encryption software, controllers should carefully weigh the quality and proper implementation of the encryption offered. And that, again, is the voice of experience speaking, because there are, unfortunately, a lot of circumstances where encryption has been implemented, but it wasn't done properly, or it wasn't maintained properly, it wasn't tested properly. And when they really needed for the encryption solution to come through, it in fact had failed in whole or in part. They also have this statement: understand what the level of protection it actually provides. And again, it's interesting, their word of actually here, because it's not theoretical what it provides. You got to know what it's actually doing, and that along with other portions of regulations imply that maintenance and testing has to be a part of the implementation of encryption in order to be able to not have to report a breach. Controllers should also be familiar with the specific of how their encryption product functions. And again, this is just a call to really know what the solution that you have, or a solution that you are considering, actually does. And as we'll see a little bit later, we've got some guidance in that area, but just be forewarned, that's not necessarily the easiest thing in the world to do. The most recent wording from the ICO in the UK on December 2018, here just last month, says you can consider the state of technological developments and cost involved when assessing what security measures to implement. And I think that's something that most of the people here know. You can consider the cost. Thank you very much. There's no reason to spend money that you shouldn't have to spend in order to get into GDPR compliance. But you do have to consider the state of technological art. And again, there's a lot of language in the GDPR around using state-of-the-art measures. And it goes on to state, however, right? As encryption is an established, well understood, and widely deployed technology that is available in a large number of solutions and can be implemented relatively easily, it is likely, again, that in many cases it will form part of the technical measures you look to put in place. So, a couple of takeaways from this here. First of all, we already spoke on one, is make sure that what you're doing is state of the art, that it's modern, up-to-date technology. Again, that's not necessarily always easy to do, because there are encryption solutions out there that are available that sort of haven't kept up with the times. And we'll talk more about how you can determine whether they have or not. And it is, some will sort of make the assertion that one particular form of encryption solution or other makes you GDPR compliant, and that's just basically marketing hype. What makes you GDPR compliant is not having a breach, and if the encryption is able to do that, then you're in compliance. But it actually doesn't have anything to do with whether or not you had a particular type of encryption, or there's not some magic that happens that if you implement so-called GDPR compliant encryption, that everything is going to be okay and you've got nothing to worry about. The other thing that you need to understand about GDPR's posture on encryption, because they do have this posture of there's a large number of relatively easily implemented solutions, that if you do have to report a breach, expect that very early in the question and answer process that you'll get asked, why wasn't this encrypted? And again, that's a reasonable question from their standpoint to ask, if their viewpoint is that encryption is established, well understood, widely deployed, and can be implemented relatively easily. So just to expect that. Just to summarize the last two slides here, what you really need to think about encryption-wise is assessing the risk to data subjects. Obviously, we all have to do that, and then select adequate state-of-the-art protections. Again, there's no reason to do that at any higher cost than you need to, but there is a necessity to be able to document that you've assessed the risk and that the protections that you have selected are adequate, and if encryption is one of them, obviously you've got to go through that assessment cycle. Know the specifics of how your encryption solutions function and the degree and scope of protection the solution actually provides. Understand what, when, and where the data is protected and when it's not. And again, this is an important caveat here. Uh, uh, there really aren't much in the way of any kind of blanket encryption solutions. The vast majority of encryption solutions that are currently in use today only cover certain data, certain times, certain places, certain times, certain use cases, right? So it's important to know exactly what the extent of your coverage is. Understand how to properly implement, maintain, test, and document your encryption solutions. Again, it's it's not enough typically just to install something, set it, and forget it. That doesn't actually happen when it comes to protective measures and providing proper documentation over time to your supervisory authority, or providing it in the event that you have reportable breaches, especially. GDPR only considers the adequacy of protection. Providing adequate protection at the least cost. That's on you. That's not on the supervisory authority. And this large number of solutions that they refer to is a sort of a classic good news, bad news story. Sorting out from among a very wide set of possible solutions, which one is the least cost and that is sufficiently adequate is typically not necessarily an easy exercise. So the basics of encryption is to make sure we're all talking about the same thing. There are 4 cryptographic data protection functions. The first we all know, and that's just encrypting stored data. The second one is cryptographic user authentication, and that user authentication extends to both humans and machines, systems interacting with systems. How do I know that the thing that's asking me for information is who it says it is? So cryptography is used extensively there. Cryptographic verification of data integrity. Again, using hashing algorithms, things of that sort, you can determine whether data has been altered, uh, whatever the cause of that alteration may be, whether it's accidental, whether it's malicious, whether it's what's called bit rot, because data does tend to degrade when it's on physical media. It tends to degrade over time. And there's just transmission encryption, the little green lock that you see when you go to a site that's got SSL or TSL turned on, and you're talking over an encrypted connection. So to this confusingly large number of solutions, we put the confusingly in because we're in this business. I've been in this business for a number of years now, and I'm confused because of the large number of solutions that work on different things in different ways, in different times, and in different places. There are encryption products for everything. I mean, there are products or services for every single application architecture, including conventional web apps, progressive web apps, which are increasingly becoming more common. And a progressive web app is one that just doesn't provide you a view into what's happening in a server somewhere, but it actually downloads content and stores it on your local device, normally in the web cache. That's why you look at modern computers and you see it, they come out of the box, you'll see that they have 2 or 4 gigabytes of data set aside to be put in the web cache. So more and more clients are putting stuff there so you can do things like post-processing and access when you're disconnected and so forth. And the standard client server applications, which are still very common, probably the most ubiquitous client server application is Microsoft Office 365. You've got the back end for the Exchange server for email and SharePoint and information that's processed and stored in Azure. Those are still tend to be just more conventional client server applications. You get cloud native applications also can be hosted in a number of places. And the cloud native application is how it differs from a conventional web app is typically it's just a bundle of services that are put together with a wrapper that enables people to do work, some type of UI that enables them to do work. And those services can come from different places, different people, different systems, and so forth, but they're bundled together to make an app. And then you have what is arguably the largest growth area, and that's peer-to-peer networks. And this is the typical network architecture for the Internet of Things. Most of those are peer-to-peer networks, and increasingly due to things like wearables in the medical world and things like that. You're getting a higher and higher level of information. In peer-to-peer networks, information that you got to figure out where it is and how to protect it. You got every kind of device type in the world, right? You got encryption solutions for servers, for desktops, for mobile, for IoT devices. You've got them for browsers, and again, the browser cache, that's becoming more important as more and more progressive web apps are made, and information, including personal information that you're responsible for, are stored in the browser. There are systems and ways to actually encrypt inside the browser and decrypt inside the browser. Every platform, Windows, Linux, OS X, and iOS for Apple, Android. There are even encryption protocols for COBOL and Fortran. So the posture of the GDPR, as they so amply expressed in their December missive, is that, hey, there's a solution out there. You should take a look and see if you need to do it based on risk, and if so, sort out whether you're going to implement it or not, and document how you made that decision. A lot of the encryption solutions, and this is particularly true of more legacy encryption solutions, are bolt-on encryption solution, or at least that's the shorthand that we use for them. Bolt-on encryption solutions, they're separate from the app that creates or stores the data. And in a lot of cases, bolt-on encryption solutions will protect several applications at once. So they protect the data that the application produces, whether it's storing it or transmitting, but they don't actually have a direct tie-in to the application itself. These tend to be centralized and pretty highly specialized encryption applications, or hardware, or services, or APIs that other applications can access. You get cryptographic authentication applications and services. Those are usually services in a lot of cases that are related to single sign-on, where no other cryptographic services are provided, but you do get sort of a universal cryptographic authentication service, and you get separate encryption key generation and management services and hardware. Those get used a lot in database environments. Pretty much every modern database has the ability to encrypt and decrypt data inside the database, normally with a pretty fine degree of granularity, but the database itself does not generate and manage the keys. It just consumes the keys and does the encrypt decrypt. So you'll need you have these external services that do that for databases. What we're seeing a lot more of, and we expect this actually to really hockey stick up in the next few years, not only because of GDPR, but because of privacy regulations that are popping up really all over the world, and that's built-in encryption solutions. And these are applications that you're going to use to process data, to create data, that provide one or more of the following, encryption functions, and preferably all of them. There's really not a good reason for them not to include all of them, and we'll talk a little bit more about why that's true. So these applications, they encrypt stored data, they encrypt the data transmission, they authenticate users cryptographically, they cryptographically verify identity, and all of that is built in. So if you're using an application that has these attributes, then the application takes care of the encryption, and you don't have to do extra work. There are encryption libraries. This is in software development kits. Libraries and SDKs are what developers use to build software. The vast majority of software today is bundles of purchased libraries and SDKs with a UI wrapper. That's become a much more common way to build software of all types, because it's fast and it's easier and it's cheaper. But there are encryption libraries and software development kits available for software developer use for every app, architecture, device, and platform. And again, this goes back to the reasoning that GDPR has for saying these things are are readily available, so you should look at them. This changes things. Probably the most public by far, and the most I think heavily marketed, and actually not just marketed but heavily supported uh, uh, application with built-in encryption today is Office 365 and SharePoint and Azure. For those of you who use the Office products, if you have an E3 or E5 higher license for your users and you have access to their security center, they really have done pretty leading edge work at embedding encryption that's highly configurable into all of their products, and they've done that specifically for GDPR compliance, although they have voluminous documentation for ISO 27001 if you're in the States and you're doing business with the military, NIST 800 171, and so forth. So they are building in encryption and adding to those functions just about daily. You'll see new possible configurations, new uses of encryption coming out of the Microsoft Office and Azure suites. That kind of causes us to advise our clients, given that these libraries and SDKs are available for developers for everything. We believe it's advisable to adopt a sort of a new attitude, and that's to ask your people that you're getting software from, why am I paying you for an application that puts me at risk? And that, of course, that's true for controllers. Obviously, it's also true for processors. There are now solutions for being able to, just as a normal, don't think of it as a, huge modification. It's a feature, right? Oh, I've got this application that I use, and the feature that I really, really want is for it to do all of the encryption for me, so that I don't have to sort all this hard stuff out, hire extra staff, or burden the staff that I already have with figuring out how to do it. So we believe that the built-in is going to you would think you're going to start people seeing advertised for different companies that offer software that get used in the processing of GDPR data are going to start, we think, in the next year or two, pretty heavily differentiating themselves from their competition by hollering, hey, we encrypt for you, so look for that. There's another breakdown of that's useful to understand, and that's packaged versus custom apps. Again, packaged apps are the old term. I'm an old guy here, so this is I remember this is when we used to refer to packaged applications as shrink wrapped, because they'd actually come shipped to you, or you'd go pick them up in a store and they'd have shrink wrap around them. Packaged applications are kind of distinguished because you don't have any real control over new features, right? So essentially, even though it's highly configurable and you can even build other applications on top of it, Office 365 is a packaged application. Adobe Acrobat is a packaged application because you don't have any real control over their feature release schedule. You may go on a blog or on a somewhere and gripe about not having a function and really needing it, and if enough people do that, it will drive a new feature. But typically you have very little direct input into how the packaged application works and what its release schedule is and what's in those releases as it matures. So the takeaway, the advice here in terms of encryption for GDPR compliance is seek packaged applications with built-in encryption, right? Anytime you can do that, and it's provided that it's good quality encryption and that you can document that, then you can offset that aggravation, that work, that cost off to the application provider, which is appropriate when you think about it because you're paying them for it. Custom apps, on the other hand, are purpose-built, and this might be existing apps, or it might be a new app that you're thinking about either building internally if you've got your own dev shop, or you might be contracting with a third party to build it for you, or you just might be buying a custom app that's specialized for whatever your industry is doing. All right. Same thing as the packaged applications. Press those application providers to build an encryption. You are paying for it. It helps you get into GDPR compliance. It's not that difficult to do, so they should do it. Another option is just migrating legacy apps. You get a lot of now migration of existing applications of all sorts to infrastructure as a service, platforms as a service, software as a service. Right, you get this migration because people want the lowered cost and the efficiency of working in the cloud, driving all of that. Just make sure that whatever platform you choose or whatever fill in the blank as a service you choose, if you're going to go the migration route, features state of the art appropriate encryption. Again, if you can offset that cost and that hassle to whoever you're already paying, that's a good thing to do. Probably the most common example we're aware of. Now there may be others, but as Microsoft partners, we see a lot of this. Is porting legacy apps to Microsoft SharePoint. There are numerous companies out there that provide some pretty high power app dev tools that run on top of SharePoint, and that's again that can be a particular advantage. Not advertising for SharePoint in particular here right now, but they do have a good structural advantage is that you can make SharePoint instances very, very secure because they have highly configured, highly flexible encryption built in. So something to think about. And I'm sure over the next few years, because of all the drive for privacy and the role that encryption plays in it, that you'll see more and more platforms that you can migrate your existing applications to, or might choose to build your newest application on because you don't have to mess around with the encryption. They've done it for you. So we're going to go to the next section of the presentation here, and we're going to deal with some of the most common issues that we see in selecting encryption solutions or evaluating encryption solutions. So we're going to play just a short training video to go over that. And here it is.
And you're going to scrape off about a pea size and put it where it hurts. So today I'm just going to put it on my wrist, put that about that much on, and you're going to rub it in. You're going to rub it until it disappears. And it's that easy. Simple and easy.
Now, we want to give you 10 questions that you shouldn't be afraid to ask, and the purpose of those 10 questions is to help you to avoid what we call magic encryption cream. And there's kind of a couple of places that this magic encryption cream comes from. One is that folks who end up getting charged with the responsibility of saying, "Hey, we got to get into compliance. Just go encrypt our stuff," without really understanding or doing the assessments that GDPR requirements, that GDPR wants you to do, requires you to do, and they'll put in an application and then some sort of solution, and then they have a breach, and they get informed by a third party that, hey, a bunch of your data got dumped and it's all legible, we can read it. And then they don't know what happened because they got the magic encryption cream and everything was supposed to be okay. This is also exacerbated by a little bit of tendency on the part of some companies to be a little hypey in their marketing. When I look and I see that somebody has an encryption solution and they've got GDPR compliant plastered all over it, I always have to laugh because encryption doesn't make you GDPR compliant. Not having reportable breaches makes you compliant. So there's also a continuing problem, and this is unfortunately this is really common, is that it's pretty easy to find out what a lot of encryption solutions do, because people are very proud of that, and in a lot of cases justifiably so. but it's just as important to know what a particular encryption solution does not do. Because you have to know what the situations are where you're covered and where you're not, when, where, how, why you're covered and when you're not, because that's going to factor very significantly in the decision-making process that you're going to go through if you have a breach and you have to make the determination, a reasonable determination, if that data that was breached was in fact encrypted. Yes, it got out or somebody got access to it, but couldn't read it because it was encrypted. You need to have a pretty high level of confidence in that before you decide not to report a breach. So question number one in these 10 questions is really a two-part question. The first part is, when is stored data encrypted, at creation or sometime later? If the answer is sometime later, if that stored data is encrypted after it was created, then sort of the follow-on question is, how long is it before it is encrypted? And this is a very, very common scenario, and hopefully it's one that we can make progress on over the next few years. But it has some problems with it because the risk of breach increases the longer that data goes unencrypted, right? That's provided that it has bears information that data subject information you're supposed to be protecting. The way that, and there's just been an explosion in the growth of these kind of systems, and for understandable reason. These are good systems, classification systems that can go out and surf, large lake of data and then recognize specific data patterns and declare that this shall be encrypted. Right, and some of this stuff is obvious, right? If they see credit card numbers, if they see some kind of social ID number, certain phrases related to medical condition, or perhaps a record in the prison system. I mean, you name it, all kinds of things. Some of this stuff, or actually a good amount of this stuff, is subject to being discovered by pattern recognition. That's a good thing. When that pattern is recognized, what tends to happen is that data is usually, it's not always this case, sometimes it's encrypted in place, but usually it's transported, it's copied, or not copied, it's cut and pasted into some storage somewhere, and then that storage is encrypted. The problem is that not all sensitive data fits those patterns. So if you've got pick an amount, a terabyte worth of data that you're running a classification system, don't expect that the classification, or don't assume that the classification system is going to fit all of the data. You still might have, depending on the nature of the data you carry, a goodly amount of sensitive data that is unencrypted even after it's been classified. And understand that those systems, as good as they are and as genuinely valuable as they are for helping us get into compliance, they don't mitigate the risk of any remaining sensitive unencrypted data. So just be aware that that solution it's a great solution, and in some cases it may be the only solution that you reasonably have, but it doesn't provide total protection. The next question, question number two, is, where is it? And this is really, where does the application or applications that you have store encrypted data, both geolocation and device-wise? And I think everybody understands that fixed data storage locations need to be in GDPR permitted locales. Otherwise, that's just a sort of an obvious violation of the reg. If the data is stored in a database and on the edge, typical client server thing, and again, we'll pick on Microsoft and Outlook. You've got an Exchange server up in the Microsoft cloud, and it's in a permitted country, or any number of applications can fit that same architecture. But you've also got data in that application that's synced to your end device, or that can be inputted from an end device. Is it encrypted in both places? And again, we've seen a lot of this, is that where it'll be encrypted on, say, the edge device, because there's a mobile device management policy in effect, and it's making sure that that data that's stored on that phone or tablet's encrypted, but it's not encrypted in the server, and then we see it vice versa. So just as you're doing your data mapping, this is the most natural place to do it. When you're following those flows, think about the geography, think about all of the different devices that data is stored in, and just do a little bit of research and find out if it's encrypted everywhere. Otherwise, you may, again, have an encryption solution that's partial, you're unaware of it, you have a breach, you think you're protected, and you're not. Who has it, right? Who has access to the decrypted data and encryption keys, and how are they authenticated? And this is it's a hugely important question, right? So pretty much every solution that decrypts data grants privileges to certain persons and to certain systems to decrypt that data. So ask yourself, how is access to that system authenticated? Who has access to the systems? And this typically is the answer is multiples. I mean, for example, you may have an application that creates and stores data on a local hard drive or on a server hard drive. So it stores data somewhere and it stores it encrypted. But you may have other folks who have access to that storage who can decrypt it. Sometimes, again, depending on the encryption solution, access to the storage for somebody who has even relatively low level administrator credentials might mean that they have the capability to decrypt everything that's in storage. Don't know until you ask. So, that's why it's a question that you should ask. Understand also, weak authentication is it takes your encryption spend, and you just might as well set it on fire. Let me explain what I mean. If you have really, military grade encryption, and it's pervasive, it's thorough, it's on your end devices, it's up in the cloud, it's on your on-prem servers, and it's just as strong as it can be. But somebody can flip up a keyboard, grab a password, get in, see that data, and or decrypt it, decrypt it and exfiltrate it all. Then all of the rest of your investment in hardening storage and hardening your internet connections and so forth, kind of wasted. So our advice to our clients is, if you're not going to do strong authentication, multi-factor cryptographic authentication, don't bother with doing anything else, because you're either have had a breach and you don't know it, or you're going to have one and find out about it pretty soon. That's kind of the nature of the world that we live in nowadays. So also recognize that if somebody else holds your keys, right, they are a processor, and you need an appropriate contract with them. How hard is it, is a question you want to ask. This is question number 4. And by that we mean, how hard is it to implement, test, and maintain your encryption solution, and who is going to do it? That turns out to not necessarily be that easy a question. Because again, some encryption solutions are really, really difficult to implement and maintain properly. What I would also, the caveat is that just because you have an encryption solution in place, and maybe it's been in place for a long time, that doesn't mean that it's currently working, right? So you really have to have a testing regimen, as you do with any kind of protective strategy. You have to be ready to explain what you did or did not do if you have a breach, or just simply during an audit, right? So again, got to make sure that it's done right and it's working right. What I would advise you to do is go out to YouTube and find the video that says "Why Johnny Still Can't Encrypt." It was a great speech given at RSA conference back in the latter part of 2017 by Jonathan Geter, who is the CTO of Thales. And the Thales, I think, is now, because they've done a bunch of acquisitions here in the last couple of years, I think they're now the largest encryption services and hardware provider, at least in the Western world. So they're a pretty big outfit. And he has this 45-minute speech where he kind of runs through the circumstances where encryption is maybe difficult to implement and maintain. And it's a pretty good way, if you're responsible for implementing encryption solutions, to learn what to avoid. So it's well worth watching. It's worn out. Can we get a replacement? This is rapidly becoming a more important aspect of sussing out an encryption solution. So understand that encryption solutions decreased in strength, right? They're kind of like people. They start, the day they're born, they start dying, right? Eventually, all encryption algorithms are going to become hackable, and they'll either be declared weak or they'll be officially deprecated, which just means some governing body or standards body says, "Hey, man, this stuff is still around, but don't you use it." Also, understand that every current weak or deprecated algorithm was once, the newest, strongest encryption, right? That's just the nature of the beast. There's a huge amount of concern right now about quantum computing coming on and the ability to decrypt everything everywhere, and there's a lot of basically just fear mongering about that. And I mean, it's true that when quantum computers will be able to take again, elliptical curve AES 256 symmetric key encryption and tear it up. That's probably actually going to happen. But it's counterbalanced by the fact that the governments, intelligence agencies, large companies, people. There's already a lot of research, not just going into making quantum computers, but to creating quantum cryptography. And their goal is pretty obvious. About the time that quantum computers come out and can decrypt everything, we need to be able to change out the encryption that it currently exists to something to quantum cryptography. Right? We've got to change the way that we do these keys so that we can keep up. That means that you need to plan on replacing the encryption solution you have, or at least that the encryption solution you have has pluggable encryption. In other words, its methods and algorithms can be readily swapped out. So the only way to know whether your solutions have pluggable encryption is to ask, right, and make sure that they've got in their plans moving forward a way to rapidly change out encryption algorithms, decrypt and re-encrypt data. That's not an inexpensive process, but if you paint yourself in the corner and your solution doesn't have that capability, like they say in the movies, Houston, we have a problem. So specify replaceable encryption. Can you find it? And can you ask the question, can encrypted data be searched and modified to facilitate data subject rights? I mean, we all have to do this now, right? That's one of the new features of GDPR is that people want to have their data updated. They want you to be able to find it and prohibit its use in whole or in part. They want you to find it and erase it, right? So all of that activity requires that you be able to search data. Unfortunately, sometimes encryption solutions are not friendly to search. They may inhibit search, or simply because the data can't be searched without being decrypted in mass, or it's computationally very, very expensive to decrypt the data because of the way the encryption works. So again, just make sure when you're looking at assessing a current solution or one that you're thinking about acquiring, that you make sure that it's not going to make it harder for you to search your data, since the requirements for being able to search your data went way, way, way up with the advent of GDPR. Is that right? Yeah. How is the data integrity assured? And again, if cryptographic data integrity is pretty common, but you still have to ask and make sure it's there. Ask the scenario. I mean, be very specific about what happens if my data is accidentally altered. What happens if it's maliciously altered? How do I know that? How do I roll it back to a known good state? Right. So that is something that you need to ask, and you need to, is it there? And also, you want to ask how any sort of integrity issue is communicated. If you have evidence of alteration, maybe particularly if it's maybe a malicious alteration attack, which is pretty uncommon, but we expect for that to become more common over time here, as we unfortunately seem to be bent on drifting into more of a cyber warfare posture. Alteration attacks become very devastating to a political opponent. So make sure you understand how those issues are caught and how they're communicated. The fact that you have maybe large-scale data adulteration on stuff that you have archived, but you statutorily need to keep for some period of time, and the only way that you know that you're having an attack is that it's buried in logs that nobody looks at. That's not a good thing. So make sure that make sure you got something that's checking the integrity, and make sure that if it finds something iffy or just hard evidence of alteration, unplanned alteration, just make sure that the solution has the means to let you know that right away. Can they hear us? How is transmission encryption quality assured? And this is sort of a difficult issue in some cases. Matter of fact, it's possible in some cases, and unfortunately in other cases, it's almost not possible at all. And the reason why is, again, understand that the backbone of the internet is essentially regulated is not quite the right word, but it's pretty close by the the Internet Engineering Task Force, the IETF. And because data can basically come from anywhere and go from anywhere, you have this, and you've got different companies that are putting their, transmitting, pulling data, putting data, moving data around. There are not strong controls, right? Nobody owns the internet. There are not necessarily strong controls to make sure that everything that touches an internet packet flying around is using all up-to-date connection encryption, right? There is a lot of use of deprecated or hacked connection encryption. Unfortunately, that's kind of a pandemic that IETF has been trying to figure out how to fix for about 20 years that I'm aware of, and they haven't made as much progress as we would all like. It is particularly a problem with a lot of email clients. Understand that email, the SMTP protocol, predates the early internet protocols by almost 20 years. Email has been around for a really, really long time, in one form or another, and basically in the same SMTP protocol. So if you have sensitive information in conventional email, understand that you can take it as a given that at some point in some communications with some external parties, that encryption is going to be weak, right? You should know it because, bad people who are looking to, take your data, they certainly know it. So understand how a connection encryption quality is maintained, and really it's a question of determining, can it be maintained? Right. So the next question is number 9, and where are you going with that? And by that we mean, how is the transfer of decrypted data constrained? And this is a little bit tricky to think about, but again, you have encrypted data, but people are not able to work with encrypted data. Systems are not able to work with encrypted data, right? They've got to decrypt it in order to be able to do work in the vast majority of cases. Now, there are some specialized exceptions to that, but they're a tiny percentage of the whole. Typically, you got to decrypt stuff. You got to give people and systems the capability to decrypt stuff to do legitimate work with the information. So the question is, how is that constrained? You can do it by policy, right, or by policy only. And that's, again, you've got an environment where the people that work for you, or unfortunately, maybe somebody who doesn't work for you, who's a bad actor, who's compromised one of your good people's credentials, if they can get access to the right privilege, they can decrypt data, they can email it, they can text it, they can download it to removable media, and walk out the door with it. So is that constrained by policy only? And by that, I mean, do you just say, hey, don't do that, and come to this training and we'll tell you why that's a bad thing? Or do you go to the next level, which is a constraint by analytics? The most common forms of this are data loss prevention systems, right? That basically, yeah, again, that they scan in real time rather than scanning like the other solutions that we were talking about that are looking at large body of stored data to classify it for encryption. They're looking at data that's trying to leave your organization in real time and saying, hey, it's got social ID number in it, it's got credit card information, and it's got some key phrase in it that gets it flagged and has an administrator look to make certain that somebody's not attempting to send information outside of the organization that they shouldn't be. And then you get user entity behavior and user and entity behavior analytics, or UEBA, and that's systems that are again looking at in the case of human behavior. They're looking at somebody, what's going on here. Bob and Alice normally download 100 files a day, and they just downloaded 100,000. What's up with that, right? It catches that kind of behavior, and it does things like, again, deep packet inspection and so forth. So it's actually looking at the information and analyzing it, scanning, doing pattern recognition or heuristic analysis to data before releasing it out in the wild, so to speak. So that's a much higher, that's a better constraint. However, it still has limits for the same reasons we talked about. The scan, classify, and send to encrypted storage solutions do. It doesn't catch everything because it's not possible to build filters that catch everything. Is the transfer constrained by the application handling the data? And again, this is typically only going to happen when you have built-in encryption. That's how it's normally done, and this is commonly known as information rights management. It basically, don't get this confused with digital rights management. Digital rights management was a technology that was kind of tried and failed to keep people from basically from copying DVDs when they first came out, right? CDs and DVDs. Information rights management is the more modern term, and basically you can think of that as a set of cryptographic technologies that throw a lasso around your data, or throw a leash around it and keep that leash on even when that data is moved outside of your organization. And again, the most common example, or actually right now the only common example that I'm aware of broadly applied information rights management is Office 365. Azure, SharePoint, and so forth, because you really can put tight controls on that not only keep having a data breach because the data is stored unencrypted or having bad connections, but they actually can maintain encryption on the data even after it's departed the presence. They can determine how long people can keep information outside of your organizations. They can determine who they can forward it to or not forward it to. That's an area we expect to see grow in the next few years as more and more companies build in encryption for protection. We also expect for them, the software providers, to build in encryption as an external set of controls on what people can do with data. And we think that's going to happen for a couple reasons. One is businesses will press for it because that helps them reduce their liability. And the other reason is that it's just less expensive to do it in the app, right? It's a way for those product companies, as Microsoft is doing right now with Office 365, to differentiate themselves and say, hey, look, we know you have this encryption burden. Let us take that on for you. And the last question, number 10, is, does it play well with others? And this is, again, really related to number 9. Is encrypted data and related user activity available for analytics, for data loss prevention and UEBA systems? Again, we've seen these circumstances where folks will have an encryption solution that cannot integrate with DLP and UEBA. Right, so it can encrypt the data, but it can't decrypt it on demand for other systems. There's no interoperability, and that's obviously kind of a non-starter because you need to have the ability to be able to monitor what people are doing in that data, to be able to scan the contents of that, decrypt it momentarily for scanning and analysis. Otherwise, you can't you can't install that sort of second layer of protection, the DLP systems and so forth. So what you really don't want to do is have the situation where you already have DLP or UEBA or both, and then you buy an encryption solution and then find out after doing possibly arduous work to put it into place that you got to take it right back off because it kills your DLP and UEBA capability. So just make sure you know how it interoperates with other systems that legitimately need to decrypt that information to scan for content, certain types of content. So we're just about done. This is our last slide, and we're going to talk about documenting compliance. iComply has a guide to encryption for GDPR. For those of you who actually have the job of managing this inside of an organization. And we've gone over things here pretty lightly, but it'll give you a deeper understanding of encryption as it relates to the GDPR. We also have iComply 365's guide, GDPR encryption gap analysis tool. When we were starting this up, we looked around because we said, certainly somebody's got a gap analysis tool that we can use, or that we can, maybe customize a bit that will enable people to go off and audit their encryption solutions, either pre or post purchase, so to speak, and tell that they're doing what they're supposed to do and be able to document that for their supervisory authority. And we couldn't find one, so we wrote it ourselves. It contains methods and questions for conducting a comprehensive gap analysis. A couple of things about both of these, both the guide and the tool, is that they are written in plain language. We were very careful to make sure that you don't have to be an encryption specialist in order to be able to use these, because in a lot of cases, you're going to have somebody who's the DPO or who has overall responsibility for GDPR compliance inside of a company. They're going to need to understand what the questions are that are being asked, because they're the ones that are going to end up maybe talking to a supervisory authority or even an insurance company or something like that. So they need to have something that's plain language for them to use. But there's enough detail in it, and the way that it's written, it can also be used by the CISO or by the person who's really proficient in encryption. So we tried to write this for as broad an audience that we can. And it's also objectively written. We don't favor one kind of an encryption solution over another. We just tell you what's out there and how it works, and here's the questions that you should ask to make sure that that you have the highest possible likelihood of not having to report a breach because the data was known to be encrypted. And that's it for us. Both of these, this deck and the guide and the tool are available at no charge on the iComply 365 website. If you have questions, if you want some assistance in kind of sorting out what you should do for encryption solution wise, please feel free to contact us. We'd be glad to help, and we thank you for your attendance. Have a good day.